Good morning. My apologies that I cannot be present with you today, but I definitely wanted to finish what we were talking about yesterday with the math. And since my husband is doing school, so cool, he knows all these like nifty little tools, and I'm going to utilize it. So we left off here with the third problem in A. Suppose the temperature increases to 35 degrees. So that's here on our chart. And the relative humidity decreases to 50%. So we're looking at a change in the productivity of the termites in terms of how much wood they're consuming. When they consume wood at optimal rates, which is here 0.27 milligrams per day, they create 70 kilograms of methane per year per 1,000 termites. And so what we're looking to find is the percent change within this same productivity. We're just going to basically take a percentage of that. So in our original problem, we calculated that there was 6.3 times 10 to the 9th kilograms of CH produced per year for those 1,000 termites. And we're going to take and figure out what percentage of that we would need to calculate. So if we have 0.09 milligrams per day being produced in the new conditions, and we'll take and divide that by the old conditions, which are the optimal conditions, which is 0.27 milligrams per day. It's going to give us a ratio, basically percentage, so or decimal. If we times that by 100%, then we end up with 33%. So 33% of our original calculated amount that came from the problem number 2 of A will give us our total. So if I apply this decimal, basically multiplied by this decimal number, it's going to give me the ratio of that original amount. So I can set all of this up by, here we go, so 0.33 times 6.3 times 10 to the 9th, that would be kilograms of CH4 per year. And the computations without a calculator, right, are so 3 times 3 is 9, 3 times 6 is 18, 3 times 3 is 9, 3 times 6 is 18. So then I've got 9, 7, 2, 1, 2, 3 decimals. Oh, that's a multiplication, that's an addition there. And then I may want to, I'm going to round. So I have 2.1 times 10 to the 9th. And don't forget my units. Whoa. 2.1 times 10 to the 9th kilograms CH4 4 per year. And that is how you find the answer. You do not have to use scientific notation. You can write this out there would be 9 zeros after a 21. So it'd be a big number, but it's doable. All right, we'll continue with the fourth question in A, which asks you to explain. So here I'm gonna put a little box. Just kidding. Totally trying to put the box around it. And that didn't work at all. I like how it just crossed it out. I'll forget it. That's funny. Yeah, not working. New program. Ooh, figured out how to delete. All right, let's try this. The shape is supposed to be, there we go. So explain why the population size of termites is also affected by temperature and humidity. This question is going to require some research on your part regarding population habits and factors that affect population habits for termites. So you need to look up some of the biology of termites and prepare yourself by studying how temperature and humidity would affect their populations. So you're going to be looking at where they live, why are they able to digest wood when nothing else can, what are their mating habits, how do they live, what kinds of conditions are needed for them to build or work together, whatever it is that termites do. So that will be on you. And then question B says, it has been observed that soon after tropical rainforest is cleared, termite density increases to an estimated 6.8 times 10 to the 7th termites per acre. So that is up from 4.5 times 10 to the 7 termites per acre. Therefore, the termite population size thereafter, the termite population size decreases dramatically. What is the most likely reason that the density of termites increases when a tropical rainforest is cleared? And so you have to connect that to their population habits. And why would any population have a sharp increase when the ecosystem is disrupted? And then number 2, why do the termite populations eventually decrease dramatically? So what would cause this kind of change in a population? I'm just going to give you a little explanation in terms of like what the graph would look like. So if you've got a population that is running pretty steady, and then there is some kind of event, deforestation event, then you get a sudden rise in population, spikes, and then it drops off dramatically. The question is, why do we see this increase? What happens as a result of deforestation to cause the population to have a shift in this steady carrying capacity, and then to drop below that carrying capacity? So kind of look back at biodiversity, and then C, describe one way other than changes in termite activity that tropical rainforest destruction contributes to anthropogenic climate change. All right, so you're going to look at the services, ecological services of a forest, and connect those ecological services of the rainforest to that concept of anthropogenic change. So hopefully that helps get you supported. Remember that you are to be using paragraph format when you're writing. You want to stay away from bullet points. And in your preparation, practice your math. Have a good day, guys. Bye.